Hey everybody, welcome to the guided assignment for chapter 8. So this whole chapter talks about creating confidence intervals, which is intervals that we are a certain percent confident that a population parameter, like a population mean or the population proportion, will fall in given some sample information. So the idea is we would take a sample of people or a sample of subjects that we were testing. We would find out the mean of that sample and then figure out mathematically through statistics how certain we are or how confident we are that that sample mean represents the the population mean. And since it would be hard to just say how close that sample mean is, instead what we're going to do is come up with a range that will provide us a certain level of confidence. Okay, so that's what we're doing in this chapter. So the first thing we need to know is, are we dealing with a mean that we're trying to find, how close our sample mean is to a population mean, or are we dealing with a proportion where we're trying to figure out how close our proportion, sample proportion is to the population proportion. So once we know the answer to that, then we need to figure out, do we know the population standard deviation uh, or do we not know it? Remember, the population standard deviation is shown with a sigma. And so when we know the population standard deviation, those are called sigma known questions or problems. And when we don't know the population mean, those are called sigma unknown questions or problems. So let's go ahead and take a look at the first one. It says a simple random sample of 50 items from a population with a sigma or population mean of 6 resulted in a sample mean of 32. And now it wants us to provide a confidence interval for the population mean. Okay. So when in doubt, start with what you know. And here's what I know so far. I know that N, or sample size, is 50. I know that population standard deviation, or sigma, is 6. And I know that the sample mean is 32. Sometimes we could call sample mean X bar, right? That's how it gets denotated most of the time. And then I know I'm going to have to come up with some confidence level or confidence interval. So the confidence in this case, the first one is 0.9 or 90%. So to figure this out, what I want to figure out is some margin of error or an amount plus or minus the mean that is going to give us this interval or a range of numbers that we are 90% confident the population mean will fall in. Okay. So to do that, I'm going to need something called the alpha. And the alpha is always just 1 minus the confidence level. So if confidence level is 0.9, alpha will be 0.1. If confidence level is 0.95, then alpha will be 0.05. So it's always just 1 minus the confidence level. And once I have this information, I can calculate my margin of error. Okay. So margin of error, I can calculate one of two ways. There's a formula, which is in essence that the z-score of our alpha divided by 2. So our alpha is 0.1, so the alpha divided by 0.05, the z-score of that times the standard error of the mean, which we learned about last chapter, that will give us our margin of error. Or there's an Excel function for it that we can just punch in, and it's called confidence.norm. And then all it asks for is the alpha, the standard deviation, and the size, meaning the sample size. So that formula or function, confidence.norm, will calculate the margin of error for us given the alpha, the population standard deviation, and the sample size. So there's my margin of error. That wasn't too bad. And now it's asked me to provide the interval. So I'm going to have the lower end of the interval and the upper end of the interval. And the lower end is just my sample mean minus my margin of error. And the upper end is just my sample mean plus the margin of error. that provides my interval. So if I adjust this to show me 2 decimals, so I'm 90% confident, given all of this information, a sample size of 50, a population standard deviation of 6, a sample mean of 32, I'm 90% confident that the population mean is somewhere between 30.6 and 33.4. Once I've established that I've set up my little calculator correctly, now all I have to do is change. The new one says provide a 95% confidence interval. So for confidence, I'm just going to put in 0.95. Now I have a new lower 30.34 and a new upper 33.66. And the last one is a 0.99 confidence or a 99% confidence interval. So my new lower is 29.81 and my new upper is 34.19. You'll notice that as I increase my confidence level or the confidence level of my interval, that the interval will get wider, meaning I have to kind of make a wider dispersion of the numbers in order to be more confident. So I'm 90% confident that it falls between 30.6 and 33.4. But in order to be 99% confident, I've got to have it fall between 29.81 and 34.19. So there is doing a population mean when our sigma or our population standard deviation is known. So the next problem, well, let's just look at it. So the International Air Transport Association surveys business travelers to develop quality ratings for transatlantic gateway airports. The maximum possible rating is 10. Suppose a simple random sample of 50 business travelers is selected and each traveler is asked to provide a rating for the Miami International Airport. The file Miami contains the ratings obtained from the sample of 50 business travelers. Develop a 95% confidence interval estimate for the population mean. So I'm going to click on this, and that's going to download it to my downloads file. I'll open it up. So there is all of my data. So my first question is, am I dealing with a mean or am I dealing with a proportion? And I guess what we're looking at here is we have a whole bunch of ratings and we're going to find the average of these ratings, okay, the mean rating. So it's asking us for the population, the estimate of a population mean. So this is a mean. And the second question is, do I know the population standard deviation? And the answer is no, that's not given to me anywhere in here. So what I need then is to figure out my sample size or my n. I'm going to need to figure out my, let's see, what else do I need to figure out? My mean or my average of all this data and my sample standard deviation. I'm given my confidence level. And from that, I can always calculate my alpha. All right, so let's figure out what I know. I know there's 50 points of data here because it's told to me that there's 50 travelers. I could count them up here. I could also use the Excel function count them up for me if I don't trust myself. This comes in handier if we're looking at like a giant thing of data and we don't want to have to calculate it. So it tells me there's 50. I can find the mean of it by typing equals average and then highlighting all the data. And that'll give me the average. And the sample standard deviation, I can do stdev.s. Again, highlight all the data. The confidence interval is, or confidence level is given to me, 0.95, develop a 0.95 or 95% confidence level. And my alpha is 1 minus my confidence level always. All right, so I have all of this data. And so now I'm ready to figure out my margin of error, and then from my margin of error, I can figure out my interval. Okay, so when I when I don't have the population standard deviation, instead I have to use the sample standard deviation. And as you can imagine, the sample standard deviation is not a perfect match or a perfect estimate of the population standard deviation. So in order to use it, I need a wider, more dispersed um, um, distribution. So I can't use the normal distribution. Instead, I'll use the t distribution. So remember, the student's t distribution is just like a wider, squattier version of the normal distribution. So to find the margin of error, I'll do confidence dot t. And again, we'll put in our alpha, comma, our sample standard deviation, and size, where size is our sample size. That gives me the margin of error. And then I can figure out the lower end of my interval and the upper end. And the lower, again, is just going to be my mean minus my margin of error. And my upper is going to be my mean plus my margin of error. And wants it to 2 decimal places. So I'll have it do the rounding for me so I don't make a mistake. So we are 95% confident that the true population mean, so if we were able to survey every single person, international traveler at Miami airport, that the true mean rating they would give would be somewhere between 5.73 and 6.95. So let's double check our work. And we're good. All right, let's go on to number 3. So number 3 now is asking us, let's see, use 6.84 days as a planning value for the population standard deviation. Assuming 95% confidence, what sample size would be required to obtain a margin of error of 1.5 days? Do not round intermediate calculations, but round your final answer to the nearest whole number. So they're asking us, given a certain confidence level and given a certain estimate for population standard deviation and a certain margin of error, what is n, or the sample size that we are going to need uh, to get that level of confidence? So unfortunately, there's not an Excel function for this. We're just going to have to create our own calculator, really. So again, I'll start with what I know, and then from there, we may have to, figure out a formula. So we know that we're going to use 6.84 as our estimate for population standard deviation. We know we have confidence of 0.95, which gives us an alpha of 1 minus the confidence level, or 0.05. And then our margin of error for this first one is 1.5. So that's everything we know. Now, let me pull up the function, or the formula for figuring this out so I can show it to you. So I'm going to pause this video just a second while I pull up that formula. All right, so I paused that for a second and pulled up the textbook, and I just wanted to show you how we arrived by this formula. So I mentioned earlier that the margin of error, they call it E. I like to call it ME for margin of error, but they call it E, equals the z-score of our alpha divided by 2 times the standard error of the mean, which we learned last chapter, which is just the population standard deviation divided by the square root of n. So if we know that formula, we can resolve it for n, right? So where n is the sample size. And so that's what we're trying to figure out, is how big of a sample do we need to get this level of confidence given this level of standard deviation. Okay, so if we solve for n, we end up with this formula right here, where n equals the z-score of alpha divided by 2 squared times the population standard deviation, or sigma, squared times the margin of, or divided by the margin of error squared. So that's just a restatement of our margin of error formula, which we already knew. So once we do that, we can now calculate it, and we can use Excel to do that, or we could do it with a calculator. So I'm going to go ahead and I don't know if it'll let me shrink this down or if I have to close out of the book here. And then we'll go back to that view. All right. So this is all our numbers that we know right now. And like I said, we know that we're going to figure out the n by having the z-score of our alpha divided by 2 squared. So I'm going to find the z-score of our alpha divided by 2 to start with. I'm just going to call this the z alpha divided by 2. Yeah, you can call it whatever you want, but I know what my alpha is. So if I just do equals norm dot inv, oops, sorry, norm dot s dot inv, and then I put in my alpha and divide it by 2, that will give me the z-score of my alpha divided by 2. The only problem with this is it's going to give me a negative version of it because it's giving me the z-score of something that has 0.025 or less. So for these problems, it really works best if it doesn't work best. We need to put in the absolute value of this number. So now what we're saying is, tell me the norm.s.inverse, or tell me the z-score of my alpha divided by 2, but then return it as a positive answer. So give me the absolute value of it. So there it is, 1.959964. There's the z of alpha divided by 2. And then I have my margin of error, and I have my population standard deviation. So if you remember, n, according to our formula, is just our z-score of alpha divided by 2 squared. Use that little up caret, which is like a shift 6 to say squared, okay, times my population standard deviation squared, and then divide all of that by my margin of error squared. And that gives me a value for n. So again, all we're doing here is taking our z-score of alpha divided by 2 and squaring it, multiplying that by our population standard deviation squared and dividing it by our margin of error squared. And we come up with 79.877. It tells us to round our final answer to the nearest whole number. So we're going to need a sample size of 80 to get 95% confidence with a margin of error of 1.5. So now that we have all that put in, it's pretty easy to do the next one. So this is, well, what if we do it with 90% confidence? But a margin of error of 2. So we're going to increase the margin of error and reduce the level of confidence. And now we can see that we have an n of 31.6. We're going to say 32. And that's it. So in real life, when you're trying to figure out how big of a sample you need, you can play with what level of confidence you need. We know really that as confidence level goes up, the closer it gets to 100%, the higher our n will have to be. And as our margin of error gets higher, the lower n will be. So in this case, from the first one to the second one, we both dropped the confidence level and increased the margin of error, which gave us a much lower sample size needed. All right. So now we're ready to move on to number 4. So in number 4, we're dealing with a population proportion. It tells us a simple random sample of 400 individuals provides 100 yes responses. What is the point estimate of the proportion of the population that would provide yes responses? So I'll start with what I know. My N, or sample size, is 400, and my yes responses are 100. So my sample proportion, sometimes that's called P bar, okay, is just my yes responses divided by N. So 25% of the people that were asked in the sample said yes. So the point estimate of the proportion of the population that would say yes is going to be 0.25. So we're going to assume that if we asked, a million people, or however big the population is, that it would still be 0.25. But we know that's not exactly right. So we're going to use these tools again to help us create a range or an interval where we're 95% confident in that number. So what is your estimate of the standard error of the proportion? So we learned last chapter how to calculate the standard error of the proportion, which is just the square root of P, just the sample proportion, times 1 minus P divided by N. Again, you want to make sure you get all of that in the parentheses so that the square root applies to all of it. So our standard error of the proportion, rounded to 4 decimals, is 0.0217. And then our margin of error, again, is just our z-score, the z-score of alpha divided by 2 times the standard error of the proportion. Okay, so let's figure out a couple other things. We'll put in our confidence level, which was 0.95, and our alpha, which is 1 minus our confidence level. So now we can find the z-score of alpha divided by 2. Z alpha divided by 2. So I just need to come in here and equals norm dot s to inv. And then for my probability, I'm going to do the alpha divided by 2. But again, this is going to return me a negative number. So, and I need the positive version of it. So I'm going to do ABS for absolute value. And now I have the absolute value of the z-score of alpha divided by 2. So my margin of error will be my standard error of the proportion times the z-score of alpha divided by 2. And now to do our interval, we'll have a lower end to our interval, which will be sample proportion minus margin of error, and an upper, which will be our standard or our sample proportion plus the margin of error. Wants us to 4 decimals, so we'll let Excel do the work for us. So we are 95% confident, given that our point estimate of 25% and that we have a standard error of the proportion of 0.0217, we're 95% confident that the true population proportion would be between 20.76% or 0.2076 and 29.24%. So that gives us a pretty good idea of how the population probably feels about whatever this is we're asking them. So we'll check our work to be sure, and we're good. Okay, one last one. All right, at 99% confidence, how large of a sample should we take or should be taken to obtain a margin of error of 0.045 for the estimation of a population proportion? Assume that the past data are not available for developing or planning a value for P, for the proportion. Round up to the next whole number. All right, so again, we'll start with what we know. We know we have a confidence level of 0.99, which means we have an alpha of 1 minus 0.99. And we know we have a margin of error, 0.045. And we don't know what P is. And so if you watch the lecture, you would have heard me talk about this. When we don't have a anything to base it on, we're going to use a P value of 0.5. And the reason we do that is because it gives us the most, I guess, the most conservative estimate that the proportion is 50-50, which will result in the highest value of n. But, when in doubt, it's better to overestimate the size of sample you need rather than underestimate it. All right. So there's all the information we know. We just looked at one where we had to calculate the standard error of the proportion, which is again the square root of our p-value times 1 minus our p-value over n. And so the margin of error is just the z-score of our alpha divided by 2 times the standard error of the proportion. Okay. Unfortunately, we're not trying to solve for that. We're trying to solve for n. And so again, I'll pause this and bring up the textbook so you can see the formula for n. Okay, like I said, we know our formula for the margin of error, which is the z-score of alpha divided by 2, times the square root of the proportion, or in this case, the sample proportion, times 1 minus the sample proportion over n. So if we want to solve for n, we can just reformulate the same equation using algebra, right? So the formula for n is going to be the z-score of alpha divided by 2 squared times p bar times 1 minus p bar, all divided by the margin of error squared. Okay, so once we know that, we're in pretty good shape to just create our own little formula or a little function here in Excel. All right, so let's do it. So I'm going to close out of this so we can see this a little bit better. And then I'm going to all right. Okay, here we go. Oh, wait, where's the one I just did? All right, so here's what we know, right? Confidence of 0.99, margin of error 0.045, and a proportion of 0.5 because we don't know the proportion, so we're going to use that estimate there. And we know that we need the z-score of alpha divided by 2, and we need p, which we do already have, and then we need the margin of error, which we already have. So let's go ahead and find our z-score of alpha divided by 2. And again, all we're going to do is absolute value of norm.s.inv of the alpha divided by 2. There's the z-score of our alpha divided by 2. And now we can plug that into our equation for n, which is the z-score of alpha divided by 2 squared. So this number squared times p times 1 minus p. There's our numerator. I'm going to actually put parentheses all the way around that. And then we'll divide that by margin of error squared. That gives us 819.123. So we're going to use, it says round up to the next whole number, 820. Check our work, and we're good. All right, so I hope that's useful to you, especially as you prepare to do the rest of the assignments. And as usual, I hope you have a terrific week.